días a todos.
Good morning
Quería
to
empezar
everyone.
con la pregunta que aparece en pantalla.
I would like to start with the question that you can see on the screen. Ultrasound and enzyme. Is it a perfect combination? Everything seems to, but what interests us is the components that are
Los plastos,
in the plastid, those vesicles that are in the cytoplasm that we need to break. Breaking, obviously, first the cell wall to produce their extraction or to extract them and thus release the polyphenolic compounds, the polysaccharide compounds that are in the wall, and even aromas. So traditionally, the enologist has been using a series of resources, such as the ones you see here, to improve or lengthen the maceration times, to use high fermentation temperatures or thermal treatments on the grape. And of course, the case that we're going to explain today is the application or the use of enzymes. Belén will give you more data on these enzymes, but I'm going to present them in the study that is going to be explained by Belén. We've chosen Enosim Lux and Enosim Vintage. The first one having a high pectin liase activity, which is essential to break the cell wall. And however, Enosim Vintage has also pectin liase activity, a bit less than Lux, but it has cellulase and hemicellulase activity. And therefore, we are going to study, using ultrasound, which of these enzymes is better to extract compounds. And we move from traditional techniques to new techniques, emerging techniques. Antonio Morata was explaining this morning some emerging techniques, non-invasive techniques, that, for example, ultrasound. Every ultrasound is useful to extract these compounds? No. One essential requirement is to use ultrasounds with high power and low frequency. Researching on this technology since 2014. Well, since 2012, in fact, but we published our first work in 2014, up to the moment that we obtained a machine that can work on an industrial level. And the support that Agrovin got was from the European Commission. The Horizon 2020 project funded our project. And of course, the European Commission is helping us to patent this system. Ultrasound has different applications, and it can extract different compounds, such as aromatic compounds, polysaccharides, and phenolic compounds. And in the upper part of the slide, you can see that it produces an effective treatment of the grapes of the climate change, meaning that those grapes that are unbalanced in their phenolic and technological maturities, those compounds that are giving color and sugar, through ultrasound we can treat those grapes a bit earlier, if necessary, so as to produce an effective extraction of those polyphenols, so that we won't have high alcohol degree wine with right color and an adequate or suitable polyphenol concentration.
What do we know, really, about the use of enzymes and ultrasound in the extraction of compounds, of phenolic compounds? We all know that compounds that really interest us are inside the vacuoles of the skin. So, for their release to happen, we need to degrade that cell wall. And In this process, the use of ultrasound and enzymes can be a very interesting tool. But apart from this release of phenolic compounds to the mast and wine mast, it will also be enriched with material that will be in suspension and that will be able to interact with a part of those phenolic compounds that are soluble in the medium, precipitating them later on. In that case, the precipitated compounds that have been together with those materials will not be a part of the final composition of the wine. These compounds could come from the pulp or from the skin of the grape. In order to identify the importance of this breakage of the cell walls, we carried out this trial. This means that this presence of this vegetal material in suspension is controlling and regulating the final content of these phenolic compounds in wine. So we should do something in order to compensate for those losses during the process or along the process of the wine making. So the use of enzymes and ultrasounds can be two very interesting tools, as will be shown later, or just right now. Well, we have seen that enzymes favor the release of phenolic compounds because they favor the degradation of the cell wall. And in this case, the pectin-diase activity on that enzyme is quite positive. We have also seen that enzymes limit the absorption of these phenolic compounds on these cell walls, and the pectin-diase activity is also very positive. Some enzymes have the ability to precipitate the suspension or in suspension material. We are able to verify or to show or point that this special elaboration improves both color and phenolic composition, but it is important to carry out a previous or prior debourbage stage, which could be tedious but could be replaced easily if during the process we add an enzyme with high pectin-diase activity. I'm going to drink some water. But a different way to increase the content of phenolic compounds in the wine and to compensate for the losses due to the interaction of this vegetable material in suspension could be the use of ultrasounds and combine it with this enzyme with a high pectin-diase activity. And for that, we carried out this experiment. However, the application of this ultrasound really resulted in an improvement of the color. And there is a more important or more considerable extract in the content of anthocyanins and an increased value of total polyphenols. The combination of ultrasound plus the enzyme enables the best characteristics, so the value of color intensity is the highest and also the content of phenolic compounds, even higher than the ones achieved after or with the 7-day maceration wine. Highlight how the use of ultrasound, and more particularly combined with the enzyme with a high pectin-diase activity, could be a good solution when It is used during the maceration process in order to enhance the content of phenolic compounds, reducing the time of maceration by 4 days. And in the case of a more mature grape, just with the use of ultrasound, there is a significant improvement in color, intensity, and content of phenolic compounds just by applying 3 days of maceration.